So now they are able to do their changes, develop things and all. And at the end of the day, they want to log out of their systems, go back to their homes. But of course,
In this video, I'll be covering everything you need to know about merge and rebase and when and why you might want to use one over the other. We've got animations, we've got live coding samples, we've got common merge and rebase scenarios. Essentially, we've got your definitive guide right here. So let's first start with merging in this merge versus rebase showdown. Say you're working on a project and you split off from mainline to work on a feature branch. Maybe a coworker also pushes changes to mainline in the meantime. Now, once that feature is complete and tested, I'm going to be ready to merge my changes back onto that mainline branch. To do this, I'll just hop over into my terminal and make sure I have my main branch selected. Then I'll run git merge feature branch to tell Git that I'd like to bring that branch over onto my currently selected branch, which is main. Git will pop open my default terminal text editor. By default, it's going to be Vim, and allow me to add a descriptive message to that merge commit. I can either press I to enter insert mode and type my message, but I'll just leave it as it is for now. Then I'm going to press escape:WQ, hit enter, and that'll save that merge message. The result is what's called a three-way merge, because not only are we merging our branch with mainline, we're also taking into account any changes that were introduced in the meantime. A three-way merge results in a merge commit that weaves together the tips of both branches, here and here, and takes into account their common ancestor here to resolve any conflicts that may have come between the tips of both of those branches. 1, 2, 3, and that's a three-way merge. Now, this example is probably the one you're most familiar with if you've used merge before, but just like rebase, at its core, merge's job is to integrate changes from one branch to another, and that doesn't always have to be one directional. If I rewind here, let's say I'd like to incorporate the changes introduced by that new commit into my feature branch without actually merging my branch back onto mainline. This would be useful if I wanted to make sure my work was compatible with the latest changes, but I still had more work to do on my feature before moving it back over. This time, instead of checking out my main branch, I'll go ahead and check out my feature branch. Next, I'll run git merge main. Git will pop open that default terminal text editor again, and I'll optionally provide a merge commit message. I'll then run escape:WQ just like before, hit enter, and the result will be that same three-way merge commit, but it'll be placed on the tip of my feature branch instead of the tip of main. And with that, my feature branch has integrated those latest changes, but still remains functionally separate from that shared mainline branch. A quick note about this workflow: every time new changes are pushed and integrated, another merge can commit will be created. Plus, once you're ready to merge that feature, another merge commit will be created on top of main, on top of all those other ones. Now, this looks a little bit messy, but one thing to point out with merge is that we're always flowing forward in time. We're taking into account what happened in the past and adding to it, but we're never changing history. This non-destructive nature is a benefit of merge, but is it always a positive? Hold on to that thought because I have a feeling rebase can help with that. But what if no changes were introduced to that shared mainline branch as we were developing our feature branch? Well, instead of a three-way merge, would get what's called a fast forward merge. Fast forward merges happen when the feature branch is already anchored off the latest changes. You still have to take into account the tips of both branches, here and here, but since the branch is built off of the latest commit, there's a sequential history from the tip of that main branch all the way up to the tip of the feature branch, and no merge conflicts are possible. So when I run merge, Git simply will move that head pointer from the tip of mainline all the way to the tip of my feature branch, resulting in that feature branch being essentially absorbed into mainline. The original branch fades away, but the commits stay where they are, and we have a nice linear history. Let me go ahead and demonstrate this. I'll open up my terminal and run merge. You'll notice Git will tell me I've performed a fast forward merge in the output of the command. Plus, I don't actually have to specify commit message because there's no merge commit. A fast forward merge is a lot cleaner and more straightforward than a three-way merge, but we do lose some historical detail since there is actually no merge commit and our branch was absorbed. But if you prefer to keep that feature branch around just for documentation purposes, just pass the no fast forward flag to the command like this, and Git will construct a merge commit regardless of if it's able to be fast forwarded or not. But keep fast forwarding in mind because this will be important later on. Now that we know about merges, and I've teased it enough, how does rebase compare and why we want to use it in the first place? But anyways, let's get back to rebase. Well, let's go back to our original example. Let's say we want to take advantage of rebase in this situation instead of merge. We can use rebase to incorporate our collaborators' changes into our feature branch. To do this, I'll hop over into my terminal, but this time I'm going to check out my feature branch. I'll then run git rebase main. When this command executes, Git will start by simply setting aside those feature branch commits in a temporary holding area. After that, Git's going to sequentially copy each commit one by one and replay it on top of the latest commit from main. The original commits are then deleted. The result is that I've actually re-anchored my feature branch off of the latest changes from main, and in the process incorporated my collaborators' changes into my work, since my work's now based off those changes. There's an important thing to notice about this picture too. Our history is now linear, and there's a single path from our anchor point all the way up to the tip of that feature branch. This means fast forward merging is on the table. No complex merge commits, just clean, linear project history when I'm ready to ship my feature. This type of rebase, when used in conjunction with fast forward merging, is the most common rebase workflow. It allows changes to be integrated incrementally instead of all at once, and enables developers to ensure compatibility with the latest changes, but in the safety of your own branch. Now, if I were to illustrate a merge-only workflow and compare that side by side with the rebase and merge workflow, you can see just how much cleaner a rebased history really is. This is the primary benefit of using it. But before you get ahead of yourself, rebase isn't all sunshine and rainbows. Rebase avoids merge commits, but it isn't magic. You can still have conflicts. As you can see, if your feature branch changes are incompatible with the branch you're rebasing, the operation will fail and you'll need to fix any conflicts. If you're going to get a conflict when you merge, you're going to get that same conflict when you rebase. But I'm going to cover conflicts in an upcoming video, and I'm going to link that video here and at the end of this video when it goes live. But besides conflicts, there is one other critical thing to know about rebase before you go out and start using it. You see, Git considers all commits immutable, which means they cannot be changed once they're created. That also means that during rebase, when Git grabs those commits, sets them aside, and replays them, the commits that end up on our newly re-anchored branch are actually copies of their originals. You can see that if I run the git log before and after the rebase, the commit hashes are actually different. This signals to Git that these commits are brand new and have not been seen before in project history. At this point, you may be asking yourself, well, I mean, so what if they're copies? The commits contain the same changes as the originals, so, I mean, who cares if they're copies or not? Well, that's a kind of a good question, and the answer is that sometimes it actually doesn't matter, but sometimes it really does matter. If the branch you're rebasing is local only and not shared with other contributors, sure, go ahead and rebase. There's not a ton of risk there. But what if that branch is shared? In that case, you might want to rethink using rebase, and I'll give you an example of why. So say our feature branch is shared with another collaborator, and I'm just going to annotate the commits in this example for clarity. Now, let's say a third collaborator pushed a change to main, and you're going to both pull that change down. Now, say your collaborator just continues to work on that feature branch and add some commits, but you run rebase to re-anchor and integrate that latest change
is going to be telescope planets, right? Telescope planets kind of confuses me because there's all these planets, but there's the moon, but there's no Pluto. Where all of those letters that you typed, and it's centered around a lot of modularity. So telescope is super customizable, too customizable for me to explain all of the customizations in one video, but I'm going to try to give you enough to where you can get started and get an idea for how much you can do with this. So anyway, let me give you a demo of what it actually does before I show you how to install it and all that, and how to configure it and all that stuff. All right, so let's get started. What I'm going to do first is I'm going to take a look, and we just went into command mode down here. It's going to give you a command called telescope. We're going to press tab, and you can see all of the things that we can search over here. What I'm going to start with is going to be find files, because this is one of the most useful ones in my opinion. You'll notice that we have a results window here, we have a file preview, and then we have this little input box here. The input box is essentially a fuzzy finder, so if I start typing plugins, it'll kind of pull that one up and show you where all of those letters that you typed are kind of highlighted, and then we can press enter on it and then head over to that file really easily. So we can do that again, jump over to init.lua, and you can move throughout your project very easily using that. Another thing that you can do is live grep. So we can do live grep, and then we can search for like all of the to-dos in our project and then just jump over to them, or we can search for everywhere in our project where we use the text LSP. So this isn't just like it's not just symbols like text symbols or whatever. It's also just anywhere where the text LSP is, it's gonna go and look for it, right? There's another way to just get symbols if you want that as well. But the next thing I'm gonna go over is, let's see, for instance, let's go jump back here. Let's go to, well, I'll go there first and I'll show you, because the next thing is going to be LSP related stuff. So if you have LSP set up, what you can do, and I set up in LSP in the video before this one, what we can do is we can do telescope LSP, and then we can go down to definitions. And so there's only going to be one definition for this when we press enter, right? And so this is going to take us to the CMD.
What is up, my NeoVim friends? Today, I'm going to show you a few things about Telescope, and maybe I just wanted to look for the markdown files.
We'll go to the installation section of the site, and first we'll back up create our TypeScript project. We'll type space, our leader key, to engage which key, then F to find, and then F again to find files. This launches the Telescope plugin that will search for files known by Git. Normally you'd see a preview of these files, so let me zoom out just a tad. And as I search, you can see a preview of the selected file on the right. Let's open the page.tsx file. LazyVim comes pre-configured with the leap.nvim plugin to allow you to easily jump to any location, which is what I'm using here to jump directly to the first styles reference. You might have noticed the cursor and
To feed the results of whip grip to FZF, input to telescope. New one shot in a different string. Sometimes you want to apply the search to different portion of the James Space Telescope in the file path. So what we want maker next. You can
Okay, this one comes from Guilo583 on YouTube in response to a video that I did about inline functions. Guilo asked, could you please also explain the reified keyword? So yes, I intentionally omitted reified type parameters from that video just because it's a big enough topic that it kind of warrants its own video, and that's the video we're going to do today. I'll explain the reified keyword, including what it means and when you'll want to use it. So to understand reified type parameters, we first need to understand what happens to type information when we compile our project. In most cases, the type information that's in our source code is also available to us at runtime. So let's say, for example, that we're targeting the JVM, and our source code includes a variable that's a string and a function that returns an integer. In these cases, the type information in our Kotlin code also exists in the JVM bytecode. But not all type information is available in the bytecode. So there are certain kinds of information that the compiler will omit whenever it's compiling our project. So specifically, this applies to type arguments. So for example, here's a function that retrieves the second item out of a list. Now, normally I would probably make this an extension function. It'd feel a little more natural, but because we're going to be comparing the bytecode and our Kotlin code, I'm going to make it just a regular function here. So this is a generic function, which means, as you know, that when we call this function here, the type argument is going to be string, because this is a list of strings. But when we call this function from here, the type argument is an integer, because this is a list of integers. Now, let's look at the bytecode, and then decompile that into Java and see what this function looks like under the hood. And when we do that, we see that the parameter type here doesn't have any information about the type of the items in the list. This is just what Java calls a raw type. So it's just the list without any other information about the kinds of things in the list. And the return type is not a string or an integer, it's just an object. And that's Java's equivalent of a Kotlin any. And because of that, whenever this function is called, there's also a cast back to the specific type, like you can see here for the string, and then here for the integer, it gets cast to a number, and then this int value function is called. So in other words, even though we call this once with a string and once with an integer, the compiler doesn't generate overloads of this function, like one for strings and one for integers. It just creates one that works with objects. So in the compiled bytecode inside this function, we've lost the type information. And when this code is running, we don't know know whether we've got a list of strings or a list of integers. And this is called type erasure. Now, conversely, type information that is available in both the source code and at runtime is referred to in the Java language specification as a reifiable type. And that specification also says that the decision not to make all generic types reifiable is one of the most crucial and controversial design decisions involving the type system of the Java programming language. Ultimately, the most important motivation for this decision is compatibility with existing code. So in other words, 20 years ago, when Java introduced generics, type erasure was a way to ensure backward compatibility, and that's the legacy that we've got today. Now, the fact that these types are erased means that there are some things that we simply can't do at runtime. If a type is erased, then one thing we can't do is we can't compare an object to that type or cast an object to that type. So for example, here I've changed our function so that instead of returning the second item, it tells you whether the second item is of a certain type. And as you can see, this code doesn't compile. And why is that? Well, just like with our earlier function, this type argument is erased when our code is compiled. So at runtime, we can't check to see if this element has that type here, because at runtime, that type argument won't exist. We won't know what it is. Now, instead of calling this generic function to check the type, we could simply check the type directly at the call site. And this works just fine. Since this code isn't using string as a type argument, it's not erased when our code compiles, and everything works just fine. So by putting the contents of this function directly in line here, we've got access to this type information at runtime. Now, as you recall, an inline function does basically the same thing that we just did manually. The contents of an inline function are just kind of dumped out into each call site. And so if this type can be known when we inline the function by hand, why can't it be known when we tell Kotlin to inline the function for us? Well, it can. So let's change this back so that it's calling our function. And then let's add the inline modifier to this function. And then the last thing we need to do is add a modifier to our type parameter declaration here, and that modifier is called reified, like this. So with the function inlined and the type parameter reified, this code compiles just fine. The type argument's going to be retained at runtime, so in other words, it won't get erased, and this code's going to work as expected. Now, like before, let's decompile the bytecode into Java, and we can see that our type check is simply written inline here, and since there's no generic function call, there's no type erasure, and everything's good to go. Now, there are other cases when we might want to pass type information along to a function. And one very common use case for this is when we're deserializing a string into a model. So we could run into this when we're using libraries like JSON or Jackson, or maybe when creating an object from a record in a database. But to demonstrate this today, I'm going to be using JAXB to turn this XML into an instance of a class. If you're not familiar with JAXB, that's totally fine. The main idea is that it's going to use these annotations to automatically instantiate an object with the values from the XML. So it's a lot like Kotlin X.serialization, but it works with XML. Now the challenge is that we need to tell JAXB which class it should instantiate for this XML string. And in order to pull this off in Java, the way you usually see it is that we pass a class object like this. And so in this case, our XML string would be deserialized into an instance of product because of the second argument. And unmarshal, by the way, when you see marshal and unmarshal, just think serialize and deserialize. Now, if we find that we're repeating this kind of expression maybe throughout our project for different files and different class types, we might want to create a small extension function to do this for us. So let's do that. We'll create an extension function on unmarshaler, also called unmarshal. And then we'll just call through to the underlying function. And now we can update our call site to use this new function. So let's go here and take this out. Okay, great. That works, but with reified type parameters, we can actually eliminate that second parameter that we've got there. So let's take it out, both from the call site and from the function declaration. And we'll get the class object off of the type parameter, like this. Now here you can see we get a compiler error, And as you probably guessed, that's because of type erasure. The type argument is erased, and so it's not known at runtime. And the solution, of course, is to change this to an inline function and mark the type parameter as reified. And now we've got a lot less boilerplate at our call site. Kotlin's using type inference to figure out what type to use here. And since we're assigning this to a variable of type product, product is going to be the type argument passed to this unmarshal function. And alternatively, of course, we can just explicitly set the type argument here if we wanted to, like this, in which case we could remove the type from the variable declaration. But my preference is usually to infer the type of the type arguments instead of the type of a variable, so I'm going to put it back. So as you can see, by inlining our functions and marking our type parameters as reified, we're able to step around type erasure and achieve things that we couldn't do without it, such as comparing types and getting the class object. Now, like everything, there are a few trade-offs to using reified type parameters. One of them, of course, is that the function has to be inlined, and as we talked about in that previous video about inline functions, that basically duplicates the body of that inline function everywhere that it's called. And so you want to keep your inline functions small in order to avoid really bloating your compiled artifacts. Also remember that an inline function can be called from Java. It won't be inlined, but you can call it. But an inline function with a reified type parameter cannot be called from Java. So if Java interop is important for the project that you're working on, just keep that in mind. If you'd like to know more about how inline functions work, I'll link to the previous video where I cover inline functions, including the inline, cross-inline, and no-inline modifiers. If you'd like to know more about Kotlin, you should join hundreds of other Kotlin developers who have signed up for my new email newsletter, where you can be among the first to know about any new articles, videos, and projects that I'm working on. You can do that at newsletter.
Hi, welcome to Kotlin Design Patterns. I'm your author for the course overview. What we'll learn in this course. We'll start off with section create objects without having to directly invoke the constructor of the class. In section 3, working with the singleton pattern itself. without having to subclass it. In Section 6, Applying the Chain of Responsibility pattern, we'll talk all about how you can transfer the handling responsibility of a task to a multitude of handlers who can go through the task itself and try to figure out who is responsible for implementing it. In Section 7, Implementing the Observer pattern, we'll talk all about how classes can notify one another when one of them changes without having to hold an instance of that object itself. And in Section 8, Tips on Design Patterns, we'll talk about using design patterns in your own class and some real-life examples of design patterns. The prerequisites for this course. The first is that you have some experience with Android. I would say this is an intermediate course. It's not very beginner, so you should know a little bit of Java or Kotlin already. You should be familiar with object-oriented programming principles. These are encapsulation and things of that nature. You should be pretty familiar with these things. We won't use them directly in this class, but you should be at a level where you understand these things. And finally, you should have the desire to advance your skills as a software developer, because that is what this course is all about, advancing your skills as a software developer to take it to the next level. Who is this course for? Some coding experience in any language is helpful, but you don't need it, but it is helpful. Even if you are a pro, you can still benefit from this course. However, you must be eager to be a wise developer and learn from other people's mistakes, because ultimately that is what design patterns are. Others have found solutions to a problem that you are facing, and they've basically given you the solution for you to use. You must be ready to start thinking about code in a different way. When you first start, you just want to print "Hello World." Your goal is just to make it work, as they say. And faced with one of these 6 problems that we'll talk about, changing it or adding subclasses that serve, wouldn't it be nice to provide some objects using you need? Otherwise, you have parameters in them and you just get lost in all the parameters. If the constructor changes, you have to change the usage code as well. If the constructor has a lot of parameters, makes it that much worse. Practical uses of the factory pattern. So let's say we have a function or a factory method for each car that returns it. So it's a public static method, and it's called getHondaAccord. Now what it does is the first time it creates a usage of this function, much easier than it is than having to manually invoke the constructor over and over again on your own. Kotlin Design Patterns. I'm your author for the course. My name is Yusuf Saber. I've worked over 6 years as a professional Android engineer. I've worked at many startups as well as mid-sized and large companies. I currently work for Vocera Communications as a senior Android applications engineer. The apps that I've worked on have been downloaded over 50 million times in total. I also hold a master's degree in software engineering. The course overview. What we'll learn in this course. We'll start off with Section 1 in a more complex way. So, what are we waiting for? Let's get... Hi, welcome with Design. This is the best way to do it. A programming example would be to add functionality to a final class. This is the best approach, as we'll see in this course. The 3 categories of design patterns. First is design patterns that simplify the architecture of a software system. such as a mobile app. Finally, we have behavioral design patterns, and these are design patterns that deal with communication between objects and entities. The 6 patterns that we'll discuss in detail in this course. The first is the builder pattern, and this is used to delegate the creation of an object to a separate object that builds the object for you. The singleton pattern allows us to ensure that only one instance of a class can ever exist, and that instance can be used throughout the application. The factory pattern defines for us an interface for creating an object from a class or a subclass based on the need of the requester. The decorator pattern allows us to add functionality to an existing class without having to subclass it. The chain of responsibility pattern allows us to pass a task through a chain of handlers to let the most fitting one handle the task appropriately. And finally, the observer pattern, which allows us to notify a set of classes of a change that occurred in a different class. The app that we'll build is called Kotlin Clothes. It's an app for creating outfits and adding them to a shopping cart. In this course, we will build the backbone or the structure of the app. It will be your job to build the UI for app however you like, on top of the core functionality that we will build together using an array of design patterns. In every section, as we move throughout the course, we will add a component into the app that will demonstrate the design pattern that we're discussing in that section. Section structure. Clothes to demonstrate the pattern design pattern. Hi, welcome to abstraction, polymorphism, and inheritance, and testability, meaning you can easily write unit tests into your code. We'll also talk about thinking more about application architecture, taking your skills to the next level. Every job has different levels that the worker must go through. For example, a plumber. Plumbers start off as technicians or an apprentice learning from other plumbers. They then move on to a pipe fitter, and then a pipe layer, and then a project manager. And after that, they can run their own business and have other employees under them. Or a policeman, or a police officer. They start off as an officer in the line of duty. After that, they get promoted to a sergeant, a lieutenant, a captain, and then finally the chief of police. So each of these is a level that the policeman must go through. A career in software development is no different than this. We typically start off as junior developers, handling simple tasks such as fixing minor bugs, adding simple features, or even testing an application with the QA team. At this stage in our careers, we're still learning a lot and we really don't know much about software. However, we get to work with developers more senior than us, intermediate and senior developers, and this really helps us get our feet wet and get our neck in the game a little bit. We typically know very little about actual software in this point in our careers, and we know there is a long way to go to becoming a senior developer or an applications architect. Then we level up to intermediate developers where we can get more advanced tasks such as fixing complex system-wide bugs or even multi-level bugs that involve entities outside of our direct application. We get to work with third-party libraries to do more complex work in a shorter amount of time. At this stage, we start combining various things that we learned from when we were junior developers. And it's at this stage that we become more accustomed to design patterns and using them in our day-to-day coding tasks. The third and most widespread stage for developers is being a senior developer. Here, we can be responsible for an entire application on our own. In this stage, we are typically the go-to person in our field in the company. At this stage, we typically teach or work with junior and intermediate developers about how the application should be designed and which design patterns should be used so that we can have the best possible architecture for the application at hand. Some companies even have application or systems architects as well. And here, you're responsible for the work of multiple senior developers, and perhaps you can be leading the teams of multiple applications or systems at one time. When we start off learning about code, we typically start off with basics such as what is a variable, what is stored in memory, or how is the variable stored in memory, what is an array, how can we do logical objects and the four main principles in and how it is difficult to build an entire application that is extensible, maintainable, and testations. Stones of a solid application architecture upon which rich feature procuring design patterns. Hi, welcome to Procuring Design Patterns. In this video, we are going to discuss solving problems in code, running into the same problems over and over again, solving problems in code, given them in interviews typically to test our skill level, and then returns the number of solved in a plethora of ways. There are even tests that we can run on more than one right solution, and oftentimes libraries are built that allow. These are examples of architecture existing class, but we can't subclass it. What should we do in this scenario? Or we need to ensure that only one instance of this class ever gets created in our application. What should we do to solve this problem? Or we need a way to build an object and ensure it's safe to use once it's created. How can we do this? And many more. As you can imagine, over time, many more. As you can imagine, over time, many developers and architects ran into these same problems over and over again. Not only that, but developers would run into the same problems over and over again when working on different applications. As developers worked on more projects, patterns were realized and solutions were kept in mind for the next time this problem was faced. You can think of this in a similar fashion as a life hack. If you run into so-and-so problem, a clever way to solve it is by doing steps XYZ and you'll solve your problem in a clever way. As developers spoke with one another and problems were discussed, certain solutions grew popular in the coding community. Bad patterns were rooted out and aptly named anti-patterns, meaning things that you should not do when you have a problem. Over time, the cream of the crop rose to the top and the best solutions were used whenever a specific problem was faced. Eventually, the best solutions to the problem that developers faced were standardized and formally written down for other developers to learn and were even discussed in major conferences throughout the world. Today, we have standard design patterns that are used in essentially every language out there and even taught in school courses just like this one. Join us in the next video looking at different types of design patterns. Hi, welcome to Using the Builder Pattern for Object Creation. In this section, we are going to discuss dealing with complex objects, which are objects with many properties that need to be set upon creation of the object. Building complex objects efficiently. How does the builder pattern solve our problem? The builder pattern with Kotlin. Here, we'll build it the classical way, and we'll build it using Kotlin's optimizations. Dealing with complex objects. In this video, we are going to discuss creating objects that have a lot of properties, using long constructors with a lot of parameters as a possible solution to that problem, and using short constructors with a lot of setters as an alternative solution to that. POJOs. So what are plain old Java objects? Plain old Java objects. They often have many properties. If you're unfamiliar with POJOs, they are essentially data class, or basically just a class that holds information about a real-life object. So in our situation, our POJO is the outfit class. Because it's an outfit, it's a real-life object and it just holds information. It doesn't actually do anything functional. So here's our outfit class. It has information about the shirt that we have on our class, the hat, the belt, the socks, the jacket, and whatever other accessories that you want to be in our outfit. They are held within the outfit class, and that's why it's a POJO, plain old Java object. So here we have the constructors for the outfit class, both in Java and in Kotlin. As you can see, the first way we can create a constructor for a class that has a lot of variables is to have a lot of parameters in our constructor. That way, when we need to create an outfit, we can simply pass in the accessories that we want. We can pass in the shirt, pants, shirt, shoes, shirt, hat, glasses, whatever we want. Now you can see the big problem with this is that there are a lot of parameters. That's a big problem. If we want to add more parameters or more accessories, we need to make the constructor even longer. So some problems with this approach. What if we don't want to pass in a parameter? So going back to the previous slide, what if we don't have a hat or a belt in our outfit? Then what do we do? What if we want some properties to have default values? So what if we want to have a default shirt if the user doesn't want to specify, let's say we want to have a plain white t-shirt as the default shirt for our outfit, no matter what the scenario is. How do we do that if we have to pass in a t-shirt every time? The constructor is long and lots of parameters are difficult to work with. As I mentioned before, there's a lot of problems with this. It's difficult to work with a lot of parameters. It's difficult to remember which parameter goes where. You might forget that the shirt is the first one and then the pants are the second parameter. You might switch them around accidentally and you start running into errors. Run your code. Now here is the other possibility for dealing with classes that have a lot of variables. The way we would do it is we would have an empty constructor. So you see here class outfit, meaning our constructor is empty. So we would create the outfit, but there would be nothing in it. There would be no shirt, no pants. No shoes, nothing. And then we would use a lot of setters. So we would say outfit.setShirt, outfit.setPants, etc., etc. As you can see in the usage, on the right component of the screen. Now, there are problems with this approach as well. The first problem was that, well, what if we don't want to pass in parameters? And that's gone now, because if we don't want to pass parameters, we simply don't need to set them. But what if we want to have some properties to have default values? We still can't do that unless we manually go out of our way to create a default object and set it every single time. But that doesn't really make sense, because if we have to set it every time, it's not really a default value. The constructor is short, which is good, but there are still a lot of setters to remember, so it's sort of the same as having a long constructor. And the biggest problem is that there is potential to have an incomplete object, because when you're creating an outfit that's empty with an empty constructor, it means you don't have a shirt, you don't have pants, you don't have shoes, you no belt, etc. So you can potentially have an outfit with nothing in it, and that's problematic for the rest of the code, because as the business logic goes, you're expecting an outfit to have shirt, pants, shoes, etc. So if you're able to create an object that is empty, that is incomplete, that's not good for the rest of your code, so it's a really big problem and it should be avoided at all costs. There has to be a better way, and there is, with the builder pattern. We'll see a better way to overcome all of these scenarios that are causing us a lot of problems. Join us in the next video, Building Complex Objects Efficiently. Hi, welcome to Building Complex Objects Efficiently. In this video, we are going to take a look at the theory behind the builder pattern, how the builder pattern solves all the problems with the previously discussed approaches, how to implement a builder class, and finally, how to use a builder class. So the previous two approaches, there were some problems. The first one, where we had a long constructor with a lot of parameters, some of the problems were the constructor was too long and it's difficult to deal with. You must provide all the parameters. And that can be problematic because sometimes you don't want to pass in a parameter. There's no space for default values. You have to pass something in. Lots of parameters are difficult to work with, not only for the reasons that we mentioned above, but also consider the scenario where you're using this constructor in many places throughout your code, and then the constructor changes. Either you add an extra parameter, or you remove a parameter, or even worse, you change a parameter. It just becomes harder to change it everywhere in the code as well. The second approach we had is that we make the constructor empty, and we have a lot of setters. But as we mentioned, the biggest problem here is that that leaves us with an incomplete object, and that can be problematic if it's created and used throughout the code in an incomplete state. There's still no space for default values here, and there are still lots of setters to remember, so either way you have a lot of stuff to remember and it can get confusing. However, it is a little bit less confusing when you need to set things rather than set them to a long list of parameters, as was the case with the previous approach. We'll start with showing how to use the builder pattern, and then we'll go into how it works. So here you actually create a builder class. So you need to create a builder class, and that class will build the object for you. So here we're creating an instance of the outfit builder. Once we set the outfit builder, we have setters, just like the second approach that we previously mentioned, but you'll see how they're different now. So you set the shirt, the pants, the shoes, and then you invoke .build, and now you have your outfit. So did you notice the subtle but very important difference here? The difference is we're not creating an incomplete object initially. We're not creating an outfit and then adding everything to it. We're creating a builder and then adding everything to the builder. And then once we have all the information set up, we can then invoke .build and get our outfit out of it. So the usage is sort of similar to the second approach where we have an empty constructor and a lot of setters, but you can see that this is safer to use. So how does it work? Here, we have a demonstration of our outfit builder class. You can see here we have three variables at the top: shirt, pants, and shoes. And then we have the setters there: set shirt, set pants. We should have a set shoes as well. And the important thing here is that we return the outfit builder for each of the setters. So for set pants, we accept a pants as the variable, but then we return an outfit builder. We return this. Similarly, in the set shirt, we return an outfit builder and we accept a shirt as the parameter. We set it and then we return this. This, of course, being the outfit builder itself. And that allows us to set the shirt, and then we get an outfit builder back, and then we get an outfit builder back, and then we can now set the pants, and we can set the shoes, etc., etc. And each time we do that, we're setting the value in our class member, and then we're returning the same object back so that we can continue adding things to it. Finally, the build function. In the build function, we're actually returning an outfit, which is what we need. We need to build an outfit. So here, we're able to do some checks. For example, we can check if the shirt is not null. We can verify whatever you want, or you don't have to verify. You can just return the outfit, a new instance of the outfit with the parameters that were passed in with the setters. So you can see now how much easier it is to create a safe object as opposed to creating an unsafe object. Here, we're able to set default values. Here, I've created functions just for the demonstration of the pattern: simple white shirt, simple blue jeans, and simple sneakers. These are just implementations that create a default sneaker, a default pants and shirt, and that way, if the setters are never invoked and we simply invoke build, we'll have the default values to plug in. And now the usage, you can see, has another advantage. If we don't want to have shoes, we can remove the last line there, outfit builder.set shoes, and now we don't have shoes anymore. And we can also have them in any order. We can set the pants before we set the shoes, it doesn't really matter, because the variable will be there in our builder for when we invoke .build. Join us in the next video, the builder pattern with Kotlin. Hi, welcome to the builder pattern with Kotlin. In this video, we are going to take a look at implementing a builder class in Kotlin, using a builder class in Kotlin, and finally, using named and default parameters to simplify the builder pattern. Now let's head over to Android Studio. We can see here in the code that I've created a class called Outfit Builder. As we saw in the previous video, the Outfit Builder class has 3 parameters: shirt, pants, and shoes. You have setters for each of them, where you just set the variable that you get from the parameter, and then you return the same Outfit Builder here by saying return this. And that allows us to create an instance of Outfit Builder and then set the shirt and the pants and the shoes, and then invoke build to get the outfit. Here, we said we can do some checks as well. I'll leave that open for now, but you can add them if you like. And once we have this set up, we can go to main activity and create an outfit simply by saying outfit equals outfit builder dot set shoes dot set shirt dot set pants dot build. So here we don't even need to create a separate variable of the outfit builder. We don't need to do this. Variable outfit builder equals outfit builder, and then outfit builder dot set shoes or set shirt, right? Dot dot dot, etc. etc. We don't need to do that. Anymore. We can just do it all in line. And that's because we're returning an instance of the outfit builder when we set up set shoes, pants, etc. So that all throughout this code we have an outfit builder class, and then we can just say outfit builder.build and we have our outfit. So I'm going to go ahead and remove this because we no longer need it. Now we have our builder class. But let's say we want to make it a little bit more flexible and we don't want to have to add a new function every time we want to add a new piece of clothing. So what we can do here is I've created an interface called clothing. There's nothing in it, it's empty. It's purpose, it's just to group classes together. So I've called it clothing, and then what I'll do is I'll go into my pants class and I'll make it implement implement clothing, so that the pants is a article of clothing. And then I'll do the same thing with shirt. And finally, I'll do the same thing with shoes. So now all three of these implement the clothing interface. So if we go back to Outfit Builder now, I can simply have an array list. So I can say val clothing equals array list of type clothing. Then we can simply have a simple function here. Let's make it public, of course. Add clothing. And we'll take in an item of clothing. Then we'll say, you know what? Let's call it clothes. Since it's a plural, we'll say clothes.add clothing. And then of course we need to return this. So here we have to have a return type of type outfit builder. So now we can get rid of all these set shirt, set pants, etc. etc. And simply we can have adding items with this function. So here we'd have to change the build function to be a bit more complex. What we'd have to do is we would say we'd need to iterate through the clothes list. So we would say clothes.for, and then we would select the curly braces, and we would essentially say if it is shirt, then we can say shirt equals int. And what does this mean? You might be confused with what it is. It is the way we access the item that we're looping through in Kotlin. You can see here Android Studio gives us a hint that says it is a piece of clothing. So here we're saying if it, which is the clothing item, or the element that we're looping through, if it's a shirt, make it a shirt. Then we can say else if is pants, then the pants item is it, etc., etc. Then we can leave our last line as it is to create the outfit object for us. So that adds a little bit more flexibility. And if we have it set up this way, we can go back to our main activity, and then we can create another outfit just like this. adding items with this function. So here we'd have to change the build function to be a bit more complex. What we'd have to do is we would say we'd need to iterate through the clothes list. So we would say clothes.for, and then we would select the curly braces, and we would essentially say if it is shirt, then we can say shirt equals int. And what does this mean? You might be confused with what it is. It is the way we access the item that we're looping through in Kotlin. You can see here Android Studio gives us a hint that says it is a piece of clothing. So here we're saying if it, which is the clothing item, or the element that we're looping through, if it's a shirt, make it a shirt. Then we can say else if is pants, then the pants item is it. Etc., etc. Then we can leave our last line as it is to create the outfit object for us. So that adds a little bit more flexibility. And if we have it set up this way, we can go back to our main activity, and then we can create another outfit just like this. We can say .add clothing, .add clothing, .add clothing. We can add a shirt, shoes, and pants. And of course, these can be out of order. They don't need to be shirt first, then shoes, then pants. We can add them in any order we like, and then we just say .build. Now, Kotlin has an even better fit class. We'll see that our variable here, it's not just variable shirt and then the type. I've also added an equal sign, and I gave it a value of plain white shirt. If you hold command and click into this, you'll see that plain white shirt is simply a shirt that has a style that's a t-shirt and a color that's white. So what this means is the variable shirt, if it's not provided, will have a default value of plain white shirt. Similarly with pants, I gave it a default value of pants, and this time I just defined it here with the style being jeans and the color being blue. Similarly, shoes is a instance of shoes with the style being boots and the color being black. So what does this all mean? And what are named parameters? Where does that come from? So if we go back to our main activity here, you'll see that outfit 3 uses this setup. we're not using the builder anymore. We're using the outfit, the actual outfit. So here, keep in mind, we're passing in shoes first. And that's because with named parameters, you don't need to have parameters in the same order that they are written in the definition. So even though our outfit has shirt defined first, we can have shoes here because we're naming it. We're saying shoes equals shoes, and then we're passing in the style we want, and the pants equals pants, and we're not even providing a shirt. You might be wondering why. Well, that's because we have a default value for the shirt. So if we go back to outfit, we'll see that shirt equals plain white shirt. If we were to remove this, and then we go back to main activity, we'll get an error here. And if we hover over it, it'll say no value passed for parameter shirt. And in this case, we would need to say shirt equals plain white shirts. We can do that here. But we don't want to do that. We want to leave it where the plain white shirt is the default value of the shirt for our outfit. And so Kotlin allows us with default and named parameters to simplify the builder setup so that we really don't even need all this builder code in our application. Join us in the next section, working with singleton pattern. Let's say we want to make it a little bit more flexible and say no value passed for a parameter shirt. And the plain white Kotlin allows us with default and named parameter section, working with singleton pattern.
But making sure the end result in the same create getters and setters as the variable are privates, so no one can access them outside. But we are providing the access through the setters and getters. The name of the method are the sufficiently self-documenting. The builder design patterns provide API for constructing an object step by step. In main class, we have create a build function, can name it get and or anything else which make the target object. So let's take a look at the example. Firstly, we are creating a person with a builder class, having private constructor with some parameters, then having a few variables declared in it. Now let's create a builder class which will be an internal class with a constructor containing parameters and init block. Like I mentioned earlier, we have to create a one internal function where it will return the object of main class. See, here I have created one internal function and named as a build, where it will be returning the object of main class. As you can see here, I have declared few variables as a private at main class level, so no one can access them from outside. So we are providing access to them through setters and getters method. So let's add few methods to access them from outside. Here you can see I have added few methods to access them from outside. Now looking at our code, we gain the ability to make our code much more readable in a couple of ways. Like the constructor is very short and simplified. It's perfectly fine to set the other properties later. Can clearly understand each and every parameter when initiating a new person, like it's like a reading English. You are clearly setting other properties and finally invoking the build method to create a person. Each logic is now isolated in separate block where we can easily follow through. When you are doing some changes, you only need to focus on one thing, which is whatever that got isolated in function block. The question is how to call it. So here is the code snippet to calling it. As you can see, we are calling builder, passing some parameter to its constructor and also setting few fields like set date and DOB. So let's have a look over a class diagram. In this class diagram, the director class doesn't create and assemble objects directly. Instead, the director refers to the builder interface for building the parts of complex object, which makes the director independent of which concrete class are instantiated. So why to use builder design pattern? Firstly, it follows single responsibility principle. states that every module or class should have responsibility over a single part of the functionality provided by the software, and that responsibility should be entirely encapsulated by the class. Having a more parameters to a constructor is not a good option to handle a product, and also using multiple constructor by overloading them with the more and more parameter also not a good option. So we can overcome this problem by using builder design pattern. So when to use builder design pattern? In some cases we need to build a complex object step by step, then we can go with the builder design pattern. And some objects are simple and can be created using single constructor, but there are some constructor which may need more and more parameter to construct the object, so we have to use builder design pattern. And suppose we want to create a custom input data type